Welcome to today's Explainer. We are jumping right into a topic that perfectly mashes up human history, biology, and some really clever modern footwear engineering. We're talking about the whole world of grounding and alternative wellness footwear. Now, I know this space is packed with bold claims, some pretty intriguing science, and quite frankly, a ton of consumer confusion. So let's demystify the whole thing.
Think about it for a second. For thousands of years, humans walked either completely barefoot or wore super thin leather moccasins, right? Our skin was basically in constant contact with the ground. But today? Well, today we walk on synthetic floors and we wrap our feet in shoes with thick rubber or plastic soles. And rubber is literally an electrical insulator. It blocks conductivity. So the big question we've got to ask ourselves is, are these everyday insulators breaking a really vital historical connection to the ground? Have we kind of disconnected ourselves from the natural electrical charge of the Earth?
To figure that out, here's our roadmap for this explainer. First, 1. The grounding theory explained. 2. What the science says. 3. How grounding shoes work. 4. Grounding versus barefoot shoes. And finally, 5. Is grounding for you? Let's kick things off with Section 1. The grounding theory explained. So what exactly do we mean when we throw around words like earthing or grounding? Well, it's defined as the practice of maintaining the body at the natural electrical potential of the Earth. And it is incredibly crucial to understand that we aren't just talking about some vague metaphorical feeling of being at one with nature. No, we are talking about a literal, physical electrical conductivity pathway. See, the Earth's surface actually carries a subtle negative electrical charge. Grounding is all about creating a literal bridge that allows a transfer of highly mobile free electrons from the ground directly into your body.
And this comparison right here is exactly why that matters. Our bodies are constantly going through this process called oxidative stress, which leads to cellular damage and inflammation. And that stress? It's driven by free radicals, which are basically just molecules with unpaired electrons that are desperately looking for a match. The theory behind grounding proposes that the Earth acts like a giant, limitless battery. It's this massive reservoir of free electrons. When you physically connect your skin to the Earth, the idea is that those electrons flow right into your body, pair up with those damaging free radicals, and basically neutralize them. The hypothesis is that doing this can reduce inflammation, speed up healing, and actually lower pain.
Moving on to Section 2, what the science says. Now, the grounding hypothesis is super compelling, for sure. But to see if the actual data backs up that biochemistry, we have to look at what happens when scientists put earthing to the test in the real world. There was a systematic review done by Adam Umbro at the Philadelphia College of Osteopathic Medicine, and he looked closely at several studies measuring people's subjective experience of pain. One key prospective cohort study, conducted by Gawley and colleagues, followed subjects dealing with chronic sleep, stress, and pain issues. And what they found was pretty fascinating. When these folks slept while physically grounded to the earth using conductive mattress pads, they experienced decreased pain and noticeably better sleep over an 8-week period. Just look at these numbers. 10 out of the 12 subjects reported a real tangible drop in their pain while sleeping. On top of that, 7 out of 11 reported that pain interfered way less with their everyday activities. There was even another randomized controlled trial by Brown et al. That showed grounded subjects had pain ratings at least 80 percentage points lower than a placebo group after the intentionally induced muscle soreness. I mean, those are some incredibly striking ratios that show genuine promise for pain reduction. But, we've got to be impartial here and talk about the limitations. That Umbro medical review makes it very clear that while these results are super promising, the sample sizes are incredibly small. That Gawley study I just mentioned, it only had 12 participants and wasn't controlled. Right now, there are very few randomized double-blind trials in this entire space, which leaves a whole lot of uncontrolled variables on the table. So the big takeaway here is that while early evidence points to reduced inflammation and pain, the actual benefits remain more theoretical than definitively proven by large-scale science. It's a field that desperately needs bigger, much more rigorous trials. All right, Section 3, how grounding shoes work. So if modern rubber acts like a total roadblock for these electrons, how on earth do grounding shoes bypass it? Well, it all boils down to a super simple 3-step electrical circuit built straight into the footwear. Step 1, there's a conductive contact point right on the outsole of the shoe that actually touches the earth. Step 2, a built-in conductive pathway carries that charge upward, shooting straight through the insulating rubber of the sole. And Step 3, an internal contact area connects directly to the bare skin of your foot. Once that continuous pathway is made, your body becomes electrically hooked up to the earth even while fully wearing a shoe. No magic involved here, just basic electrical conductivity. And that brings us to a huge, huge myth in the biohacking community. A lot of folks out there seem to think that for a shoe to truly ground you, it absolutely must have thick copper plugs or rivets jammed into the sole. But do you actually need copper to stay connected to the planet?
The answer to that is a hard no. Now, sure, copper is highly electrically conductive, but it's also highly thermally conductive, meaning it transfers heat really efficiently. If you wear copper in the winter, it's going to rapidly draw the heat right out of your foot, leaving you totally freezing. Instead, engineers use other incredibly effective materials. Carbon-infused rubber gives you this really durable, consistent conductivity across the sole without freezing your toes off. Conductive silver stitching is actually even more electrically conductive than copper, and it stays totally flexible. And honestly, even traditional thin leather soles work beautifully because leather naturally conducts small electrical charges when it absorbs just a tiny bit of moisture from the environment.
Next up, Section 4, grounding versus barefoot shoes. Okay, let's clear up some major consumer confusion right now. People constantly mix up grounding shoes with barefoot shoes. They use the terms interchangeably all the time, but they actually serve completely different purposes. Grounding shoes are absolutely all about that electrical connection. Their main job is earthing via those conductive elements we just talked about, which usually means they have a moderate sole thickness and feel a bit more snug and anchored on your foot. Barefoot shoes, on the flip side, are completely about biomechanical freedom. They've got ultra-thin, flexible soles with zero drop, and they just want your foot to move and splay as naturally as possible. You wear grounding shoes on soil or unsealed concrete to absorb those electrons, but you wear barefoot shoes at the gym or on the trail to strengthen your foot muscles. So you don't necessarily need both, but you definitely need to know which goal you're actually targeting.
And that brings us to our final section, Section 5. Is grounding for you?
So how can we actually apply all this? If you're itching to try grounding shoes out, here are some rapid-fire, highly practical takeaways. First off, skip the socks. Seriously, you need direct skin contact with the shoe's internal conductive points to actually complete that electrical circuit. Second, you don't have to just guess if your shoes are working. You can totally test them yourself at home. Just grab a basic electrical multimeter, set it to continuity mode, place one probe on the bottom of the sole and one on the inside, and listen for the beep. Third, you don't need to live near a lush forest to ground yourself. Unsealed city concrete works flawlessly because the moisture and minerals in it conduct the Earth's charge. And finally, always prioritize comfort. Look for breathable designs with good traction so you don't go slipping around.
Now, I do need to pause for a second and highlight a really crucial safety warning straight from the medical sources. Because grounding involves a very real, very measurable transfer of electrical charge right into your body, it is not just a placebo effect. So if you happen to have any electronic medical implants, especially pacemakers, grounding could potentially interfere with those devices. Always, always consult your doctor before you go introducing a brand new electrical variable into your body's ecosystem.
So we've covered the fascinating biochemistry of free radicals, we've looked at the promising but still preliminary academic studies, and we've explored the incredibly clever carbon and silver engineering that literally turns a shoe into an electrical bridge. Whether you're hoping to potentially knock out some inflammation, or maybe you just want to give your feet a break from highly insulated modern sneakers, the whole concept of earthing really does offer a fascinating new perspective on our daily habits. So the question I'm going to leave you with today is this. Knowing what you know now about how our modern soles act as literal electrical insulators, are you ready to change up your footwear and reconnect with the earth? Thanks so much for tuning into this explainer and keep exploring.